there's reason why people actually getting this coating thickness gauge. Okay, now number one is actually for cost control. Okay, now why cost control? Would you know how thick is the paint that we have actually painted on this cabinet?
No.
Okay, but I have customer actually telling me by feeling with fingertips, they can tell whether or not it is 100 micron, 200 micron, but it's not really true.
Okay.
Okay, now they can only find out by using a coating thickness gauge. Okay, now cost control. Why cost control? Usually, the customer of our customer will actually specify. Say steel cabinet, you could paint until probably 100 micron thick. Okay, so 100 micron thickness is actually one of the requirement of the quality that they must fulfill. Right, in order for their customer to feel satisfied about their product quality. Okay, now say 100 micron is the required thickness. Without a gauge, it is very likely for the thickness to spray up to 150 micron. Okay, so when it actually spray up to 150 micron, what does it mean? It is actually 50% more, okay, of the thickness that we actually spray on. Okay, for a big factory, this, when it translates into money, say a factory of some reasonable size, probably 1 month they will be using 20,000 worth of value of paint. 50% more, yeah, it's actually 10,000 more, am I right, in terms of value. So for that reason, without a gauge, they simply has got no control in terms of the cost of the paint usage. Okay, so with this, the moment they measure, okay, what they need is just they turn on the gauge, then they just they get the reading immediately. Alright, with the reading, they will be able to know whether or not the reading is within 100 micron or more. If it's more, how much more? So they will be able to control on in terms of what? The sprayer pressure, the sprayer speed, the movement, how many times of repeating spraying. So with all this, our customer can actually control the usage of paint, alright, as a raw material for the product. Okay. Now, in terms of cost control, there's actually another scenario. Now, cost control in terms of reduce the rejection rate. Our customer will actually reject the product should they actually quote lower than what is actually specified, am I right?
Okay.
So should they actually quote lower, probably for example 80 micron, right, which is probably more than 10% of kind of tolerance that their customer actually requested for. So with this 80 micron, it's actually below the specification, alright, that this customer must fulfill. So what will actually happen? Customer will reject their this am I right, and request a rework, and this rework will take times. Besides times, cost. Alright, cost of what? Ship back the item, do a rework. Okay, meaning a double job. Okay, so with the available of this coating gauge, they can actually avoid this thing from happening. Okay, right. So this is for the first reason for the usage, the cost control, right? And secondly, QC control. Okay, what is this QC? QC means simply quality control, meaning so your customer actually specify 100 micron as the specified required thickness. We just control it within this tolerance, meaning 100 micron probably plus minus 5% or 10% kind of tolerance. Alright, so and by having a good consistent quality control, a company will be able to promote their own image, alright, as a company that is actually reliable, trustable, so that you can achieve a better customer satisfaction. Okay, right? So this is the reason why people are actually going for coating thickness gauge. Okay. Alright, the reason. Okay, now this first part is actually on the why people have the gauge. Second is actually the working principle. I'm going to share with you the working principle of this. Okay. Now you actually see this this group called ferrous, F, N, and Fn. Am I right?
Okay.
Okay. The moment you see F, it actually stands for ferrous-based metal. Okay. Now, whenever we are using okay, what is this model? This model is actually Fn. Fn means it actually can be applied for both ferrous or non-ferrous substrate. Okay. Now, whenever it's actually only contain F, it means that there's a requirement of what? Requirement of the combination of the coating material as well as a base metal material.
Okay.
Say when for F, it's only suitable for non-magnetic coating on top of ferrous base metal. Okay, so whenever we actually selecting a model only carry F alphabet, right?
Okay.
It has one requirement, meaning your coating material got to be non-magnetic coating. Non-magnetic coating simply is a coating doesn't attract iron. Okay, example are paint. All right. Another example is actually electroplating. You know, this is stainless steel without coating, but there are certain metal actually has a deposition of metal on top. Example are zinc coating, gold plating, silver plating, okay, or others like copper coating. Yeah, all right. So, on top of what material? Ferrous-based metal. Okay, what sort of ferrous-based metal are actually we are talking about? Things like mild steel. Okay, mild steel or iron. Okay, or cast iron. All right, anything that is actually contain ferrous, contain ferrous. All right, okay. Now I'm going to share with you the working principle when we are actually using F mode. Inside this sensor, there is this two coil. Okay, two coil. One is actually primary coil. The other one is secondary coil. Okay. Now. Okay. I'll carry on. Now, this probe should be actually dissect it. It will look something like this. Okay. Now, this is primary coil, secondary coil. Okay. Now, when we actually measure on top of, say, for example, okay, when we're actually doing measurement on top of this metal block, there's this layer of plastic film. Say we can assume it as a kind of coating. Okay. All right. Say for example, this is the coating. Say this is the base material. This is the base metal, and this is the probably coating material. All right. Now, how they works actually? This primary coil will actually generate magnetic flux. Okay, magnetic field. Okay, they will actually generate magnetic field. Now, this magnetic field will actually interact with the base. Okay, and the signal strength. After it's actually interact with this base, they will have a feedback signal.
Okay.
Feedback signal to where? To here. Second to the secondary coil. All right, and the signal strength is actually sort of inversely proportional to the distance, separating the sensor and the base material. All right. So, with this manufacturer, they have done study how to actually calibrate so that they can actually find out what is the thickness, as correspond to the distance separation that separate the probe to here. Okay. By doing a correct calibration. We're actually using this foils of known thickness as a way to do calibration. we are telling this gauge, okay, at say for example at 241 micron, how should the signal strength should be, all right? And at 1043 mm, at somewhere around 1043 micron, what should be the signal strength? So by having this reference signal, you know, we will actually be doing calibration. Now we actually establishing the response curve. Okay. Say this is actually the signal strength, and this is actually the probably the thickness. Okay. At zero thickness, they have a certain signal strength. Okay. And for example, at 241 micron, they have certain signal strength. Okay. Say signal strength of 1. Then at that 1000 over, they have another signal strength. Okay, right? So by establishing this characteristics curve, we will be able to find out what is the thickness that actually separating this sensor and the base. So that's we translate to coating. Oh, okay. Understand so far? Okay. Excellent. Now, this measuring principle is called magnetic induction. Okay, right. Now, for non-ferrous, they have this is actually called non-ferrous base metal as the requirement for the base. Okay. Now, what sort of coating is actually for non-conductive coating? Okay. Example of non-conductive coating are paint. Okay. And what else? Plastic, rubber. Alright. Anything that is actually non-conductive. Okay. Now, and what's the measuring principle? They are actually using eddy current. Okay, eddy current. You know, it's still the same. They have primary coil and also secondary coil. They will generate the signal, alright, and this time it's actually eddy current that flow along here. Okay, eddy current that actually flow on the surface of the test piece that we are actually testing. And this eddy current will again generate a feedback signal, alright, to be detected by this secondary coil. Alright. Now, again, they also comply to this. The feedback signal is actually indirectly proportional to the distance. Inversely proportional. Meaning, the greater is the what I call the distance. The bigger is the signal they actually obtain. Okay. So for that reason, it can there is a limitation in terms of measuring range. Okay. Cannot be too thick, and different model will have a different range. Okay. Now, come to the last one, FN. The moment you see model that actually with alphabet of FN, it means it can measure both non-magnetic coating on ferrous-based metal or non-conductive coating on non-ferrous-based metal. Okay, right. So, just a quick test. Should be actually having a pane, and this base material is actually aluminium. Which model should we use? N. Excellent. Okay. Now, this time zinc coating on top of, say, mild steel. Which model do you think we should use? Zinc is actually non-magnetic coating. Okay. Why? Because zinc is actually conductive, am I right? So we need to use N. It doesn't comply anymore because all metal are conductive. Okay. So zinc is actually comply to this non-magnetic coating. How about the base? Does it comply to ferrous-based metal?
What's the base again?
Mild steel.
Mild steel.
Okay, this is actually mild steel. Alright. It will corrode. Mild steel will actually corrode. So it contains ferrous actually. Then it should use F model. Okay, right? Can?
Okay.
Excellent.
Okay.
What happened? Should a factory having both this first scenario and second combination of the coating and base material, which
Okay.
model should we use?
FN.
Yes, excellent. Okay, all right. So that would be the knowledge background that you need to know. Okay, all right.
Alright.
Thank you very much
Thank you.
for joining me.
Thank you.
Okay, all right.